example 8 on page 123. A uniform beam AB of mass 40 kg and length 5 meters rests horizontally on supports at C and D, where AC is equals to dB, AC is equals to dB, and both of them are equals to 1 meter. When a man of mass 80 kg stands on the beam at E, the magnitude of the reaction at D is twice the magnitude of the reaction at C. We are not told where E is, but we can identify. Before we go to E, the beam is 40 kg. This is just the mass. And the beam, which is uniform, the mass will be shown right at the middle of the beam. And this is 40 G, because remember we are given mass, so it has to be affected by the gravitational effect. Assuming point E is here, a man of mass 80 kg, again 80 G, is standing on the beam, and after doing that, let's hear what happens. The magnitude of the reaction at D is twice the magnitudes of the reaction at C. After this happening, then the magnitude of the reaction at D is twice the magnitude of the reaction at C. So the question is, by modeling the beam as a rod and the man as a particle, find the distance AE. Find the distance AE. That is the distance AE. And you realize that the upward force will always be equals to total downward force. So we start by saying R plus 2R is equals to 40G plus 80G, which is basically 120G. If this is true, then 3R is equals to 120G, and therefore R is 40G. That is our basic value of R. We may not really introduce G at this point, but R is 40G. Of course, you know G is 9.8. If that is true, we need to talk about what the question is all about. The question is find the distance AE. This can be one rotating point, this can be one rotating point, and at the same time, we can still make point A a rotating point. And I would wish to make point A a rotating point and assume that there's a fulcrum there. But before we can even do that, let us add some details in our question. A uniform beam. So the mass of the uniform exhibit right at the middle. And the beam is 5 meters. So the middle from here to where the mass of the beam is experienced or is felt, it should be 2.5 meters. So definitely, if this is 1 meter, then this is 1.5 meters.
The beam is 4 meters.
The beam is?
4 meters.
The beam is 4 meters. The beam is, no, the beam is 5 meters. The beam is 5 meters. 5 meters. So you can talk about, but because we are used to getting the moments around a rotating point, let us use C as our rotating point, such that we may want to talk about that distance. Let's call it X to start with. And if C is the rotating point, then we need to get moments about C. And the moment about C, clockwise moment, is affected by the 40G and the 80G. So the clockwise moment is 40G times 1.5 times 1.5 because of this distance, plus the 80G times X, which we don't know. So 80G times X, or rather 80GX. 80GX. And because the beam is at equilibrium, it must be equals to the entire anticlockwise moment. Before we can even go to getting the anticlockwise moment, the moment about C due to R is absolutely 0 because the distance is itself 0. This is going to be equals to 2R. What is this distance? The distance between C and D, of course, we know AC is 1 meter and DB is 1 meter, and the whole beam is 5 meters. So we realize that the whole distance between C to D is obviously 3 meters. So 2R times 3 meters, which is, this is 60G plus 80G, 60G plus 80GX. What about the reaction? Of course, 1R is 40. Remember that, RG. 1R is 40G is equals to 80G times 3 because 2R, R is 40G. Having said that, of course, we can now collect the like terms. This is 60G plus 80GX is equals to 240G. At this point, we can already see that 80GX is equals to 240G minus 60G, which is 180G. Having said that, our arrangement is 80GX is equals to 180G. Divide by 80G on both sides, divide by 80G on both sides, then we can realize that our X is, of course, 18 over 8, which is 9 over 4, which is 2.25 meters, of course. Now, this is our value of X. From E to C, EC is 2.25 meters. But the question is AE. The question is AE, which is definitely 1 because we have 1 meter here. AC, which is AC plus CE. And AC is 1 meter plus 2.5 meters, which is 3.5 meters. So generally, our AE is 3.25. 3.25 because our EC is 2.25 meters, which is 1. The length of AE is 3.25 meters. Okay. Yeah, that's right. 3.25 meters.